Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will demonstrate how to certify a multimode fiber optic link using a WaveTester optical power meter and a WaveSource series multimode light source. There are 5 main steps in the process of certifying any fiber optic link. These steps are gathering link information and accessories, checking equipment and accessories for proper operation, entering link information into the certification tester if available, and setting an optical reference, also called zeroing, taking insertion loss measurements and storing test results, and then downloading stored test results to a PC and printing a certification test report. Before beginning any fiber test, the user must gather the necessary link information and accessories required to complete the test. Link information is used to help determine how much loss is acceptable for the fiber under test, otherwise known as a link budget. Optical loss measurements are compared to the link budget to determine if the fiber is good or not, which is the same as saying pass or fail. There are 5 key parameters that apply to any fiber optic test. First is the fiber type, which will be either single mode or multimode. In the case of multimode, this could be either 62.5 or 50 micron. Next is fiber length. It is important to know how much fiber is in the link under test in order to determine how much loss is acceptable for that particular length of fiber. Some OWL testers can be used to measure the end-to-end length of the fiber automatically, including the FiberOwl 4 bolt optical power meter. Otherwise, the user can use jacket markings, installation documents, or other length measurement methods such as OTDR. For best results, avoid estimating the fiber length whenever possible. Third is number of connections. A connection is the point where 2 fiber connectors mate together, such as in a patch panel, wall plate, or mating sleeve. Fourth is the number of splices, which can be either fusion or mechanical. For the purpose of calculating a link budget, most cabling standards do not distinguish between fusion and mechanical splices. Lastly, the user must determine what wavelengths they will test at. For multimode, this is 850 and or 1300 nanometers, and for single mode, this is 1310 and or 1550 nanometers. When using a micro-OWL or fiber-OWL optical power meter, these parameters can be entered directly into the device to calculate the link budget. However, if the link budget needs to be calculated manually, this is done simply by adding together the fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies based on the fiber type and wavelength. To calculate fiber loss, multiply the fiber length in kilometers by the fiber loss. Connection loss is the number of connections multiplied by the dB loss per connection. Splice loss is the number of splices multiplied by the dB loss per splice. Most users will follow the fiber, connection, and splice loss specified in cabling standards, such as the TIA 568. It is also helpful to determine the connector type used in the link under test, which will help determine the right reference cable configuration to use. For accessories, it is highly recommended to keep at least 3 patch cables on hand, since there are 3 reference methods: 1 jumper, 2 jumper, and 3 jumper. Mating sleeves may also be required for some link configurations. Refer to OWL's video on reference methods for more information. Finally, if testing multimode fiber, the launch cable attached to the light source will also need to be wrapped around a mandrel according to cabling standard specifications. Refer to OWL's video on mandrels for more information. The next step in the certification process is to check your equipment and accessories for proper operation to make sure that they are working correctly for the optical loss measurement. Now, the first thing we need to do here is to make sure that we do indeed have the correct accessories, and in this case we're using the WaveTester optical power meter. We're using a WaveSource series multimode light source. Now, as you can see, there are actually 2 ports here. There's a multimode port and a single mode port. Some models of the WaveSource can have either multimode or single mode or both, or they can have VFL in either one of these ports. So make sure that you have the correct model number for the particular test that you're doing today. In the case of multimode, we have to make sure that this is actually a multimode port. So what you're looking for on the back of the unit is a serial number sticker that has a listing of the different wavelengths that are present in the light source. So the first thing we need to do now, and once we've checked that we've have all of our accessories, including our patch cables here, is to power on the equipment. So we simply press the power button on both units. And as you can see with the WaveSource, the multimode port is active by default here. In fact, if you look at the two wavelengths that are listed here, 850 nanometers and 1300 nanometers, you'll see that there's a red circle here which denotes 850 and a green circle for 1300. What that means is that you're looking at the color of the LED. So if the LED here is red, that means you're at 850. If it's green, you're at 1300. So you can see that on the WaveTester, when you initially power it up, in this case it powers up to 850, and then it'll power up to 850 when you first purchase the meter. However, a nice feature of the WaveTester is that it remembers what wavelength you were on when you power it off. So if you happen to be testing at 1300 and you turn the meter off, it'll come back to 1300. Now, to check the patch cables, we simply connect them into the ports that we're using for the test. In this case, we're using the multimode port on the light source and the detector port, as you can see here, on the power meter. What we'll do is we'll check this orange cable first. This is the cable that will stay with the WaveTester when it goes to its side of the link for testing. Okay, now you can see you have a reading of minus 20.5. Okay, really what we want to see is a reading of roughly minus 20 dBm, and this is fairly close. We want to make sure that these patch cables do not exceed minus 21. That's the goal. In this case, this patch cable is okay to use. For now, what we're going to do is we're just going to remove it from the testers, and then we're going to plug in the other patch cable. Now, we can set this patch cable aside. We won't need it for a while until we're actually taking measurements. Now, with this cable, we're going to check this one again, and again, we want to make sure that it's still reading around minus 20 dBm. And one thing I'd like to point out here is the fact that you see the word low here. What low means is that there's no light coming into the detector, at least no amount of measurable amount of light. This is because we haven't connected anything in yet. You'll see that when we connect in here, we will get a power reading. Okay, in this case, we have a reading of minus 20.79. Okay, again, remember we're trying to not exceed minus 21. But we want to be roughly close to minus 20 dBm. Could be a little higher, a little lower. It's not going to be perfectly right on all the time. But in this case, we're happy with this result. We can actually zero out this reference cable. Now, I want to note that because this is multimode, we have our reference cable wrapped around a mandrel according to cabling standards and test procedures. And this is something you do only for multimode fibers. Okay, now once we have our equipment checked, we're sure that it's good enough to use for our measurements. What we can do now is to set a reference through this mandrel wrapped cable. And this is easily done by just simply pressing and holding this unit's 0 button here. Now, something nice about the WaveTester is that if we use a feature called auto mode, and we have auto mode active on both units, we can set a reference and take measurements for 2 wavelengths at once. And that's something we can do with the WaveSource. If it's not a WaveSource, then you can't use auto mode feature like that. But for the WaveSource, this is a nice feature. What we're going to do is we're going to set the power meter and WaveSource into auto mode first. And this on the WaveTester, it's simply done by pressing and holding the lambda auto button. Now, as you can see, you have your wavelength number is alternating with AUO, which is short for auto. Now, the reason it's flashing between a number and auto is because the WaveTester is looking for an auto testing signal, but is not getting one yet. What we need to do now is make auto mode active on the WaveSource light source here. You can see the wavelength button has a second function called auto. Now, the way that we start auto mode on the WaveSource is by pressing and holding the auto button and then waiting for this LED to begin flashing. And then when it starts flashing, then immediately remove your finger. So I'll demonstrate that now. So the WaveSource is in auto mode, and if you look at the WaveSource, it's alternating between colors, so red and green, so it's putting out 850 and then 1300, and it's also alternating between flashing and solid. And this basically is the rotation of wavelengths that the WaveTester needs for its measurement. As you can see, the WaveTester is indeed switching between 850 and 1300 now. If you look, when the red is on, 850, so the red light here is on, means 850 is here. If the green light's on, then it's 1300 here. So once we have auto mode active on both units, we can simply press and hold the 0 button here. And now you can see that we've switched to dB mode, which is what loss mode is after you've zeroed. And you can see that your meter is zeroed because no matter what wavelength you see, you're reading at 0.00 dB. The next step in this procedure is to take the testers to opposite ends of the link, connect them into the patch panels, and perform the optical loss test. Now that we've zeroed out our equipment, it's time to take our optical loss measurement. The first thing we need to do is to take the light source with its mandrel wrapped reference cable to one side of the link to test. And then we take our power meter, we take it to the other side of the link. And this is where our straight cable here comes into play again. Now, one thing I want to make note of, specifically on the WaveSource, once you've zeroed out, you do not want to disturb this connection at all, because if you disconnect and reconnect, you're not assured of getting the same reference level again. So if you do disconnect, you may have to re-zero and start your testing all over. Likewise for the mandrel wrap, you want to make sure that once the cable is wrapped around a mandrel and you've set a reference, do not let this cable unwrap from the mandrel. Otherwise, again, you will have to re-zero and take your measurements all over again. So now that we've taken our testers to opposite ends of the link, it's time to connect these testers into the link. Now what I've done here is I have a box here that simulates a fiber link. So let's say side B is a six-port patch panel in one closet, and side A has a 6-port patch panel in another closet. So what we need to do first is connect our patch cables into port number 1. That's usually where we start. So we just take the dust caps off of port number 1, and we plug in our testers to port number 1. Okay. Once you connect in with the WaveTester, make sure that you let the WaveTester go through a cycle or two of 850 and 1300. Okay, what that means, by doing so, that allows the meter to have acquired both loss measurements on the screen. Okay, so we've let it do that. And the nice thing about the WaveTester, again, is because we're in auto mode, we can hit the save button one time, and it stores an 850 and a 1300 reading for port number 1. Now, when I hit the save button, you'll see what happens here. It'll say, well, because it's storing 2 readings, it'll store, or it'll show the fiber number, or I'm sorry, the test reading number 2 will show up here. Reason being is because we stored 2 readings. We stored an 850 reading and a 1300 reading together. Now I'm going to go through and test the other fibers in this link, and I'm going to speed that process up here. And finally, we store a reading for port number 6. As you can see, every time we stored a reading, our fiber numbers incremented by 2 because we were storing a reading for 850 and 1300. So we've stored readings for all 6 fibers in the meter. So the next step in the procedure is to take the WaveTester to a PC and download the test results to produce a certification report. Once data has been stored in the optical power meter, test results can be downloaded to a PC to produce a certification test report. First, install the USB driver and OWL Reporter software from the supplied CD or a USB flash drive. Connect the power meter to the PC using the supplied USB cable. And then power on the power meter. Then start the OWL Reporter program. The program shortcut can be found in the Start menu. When the software has started, the screen will initially say no data loaded as shown here. Download the test results to the PC by pressing either the download menu option or the download button. While downloading, the status bar will say searching for OWL device. Specific to the WaveTester, once test results have downloaded to the PC, OWL Reporter launches a link wizard. Users will be prompted to enter link information into dialog boxes, starting with the cabling standard. Click the arrow in the drop-down menu to show a list of cabling standards, then click on the standard to select. Once the chosen standard is selected, click Next to continue. Click the drop-down arrow to show a list of fiber types, then click on the appropriate fiber type, then click Next to continue. Enter the fiber length by selecting the appropriate measurement units, then typing the length number. Click Next to continue. Enter the number of interconnections and splices for the fiber under test. A connection is simply a patch panel, wall plate, or other mating sleeve. Likewise, count the number of total splices in the link under test. Most cabling standards do not distinguish between fusion and mechanical splices. Click the New Organization button, then enter the organization name and telephone number. Once the organization name appears in the drop-down box, click Next to continue. Enter the date of test. By default, the current date is displayed. However, if the date of test is different, use the drop-down menu to change the date. Finally, enter a descriptive name for the link under test. Once the test results have successfully been downloaded, the data will appear in the OWL Reporter screen. The test results can be viewed in 2 different formats. This view is called Circuit Detail View. It shows detailed information about a single fiber run. The other view is called Circuit Summary View. Circuit Summary View shows basic information about a group of related fiber runs. Certain buttons become active when Summary View is selected. Pass-Fail, Overhead, which shows how close the test is to its fail point, or Optical Loss. Toggle between Summary and Detail View by pressing this arrow button. Test results can be printed from the File menu or Printer button. The printout will show test results based on the currently selected view. The reports are formatted to look like the OWL Reporter screen. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.